In this lesson, we're going to talk about polynomials, and we're going to just give you a brief introduction to that. We're going to talk about vocabulary, and we're going to talk about quadratics specifically, which is a special type of polynomials, and then we're going to look at how to model them with algebra tiles. Here's some vocabulary that you might need when talking about polynomials. So first of all, a polynomial, poly, breaking it down by the root word and the suffix, poly means many, and meal means terms. So a polynomial is an expression with many terms. And an example would be 2x to the third power plus 4x minus 5 is a polynomial. So we have 1, 2, 3 terms. So it would actually be a trinomial because it has 3 terms. Tri means 3. But like polynomial is a generic word, just kind of like a polygon is a generic word for any kind of shape, but a triangle is a special kind of shape. That's what we're talking about here. So polynomial, you can refer to any expression as a polynomial, even if it's a monomial or a binomial or trinomial, they all fit underneath polynomial. So monomial would be 1 term. Mono means 1. So 4x to the 4th by itself would be a monomial. Binomial would be 2 terms. So x plus 3 is a binomial, 2 terms. And then, of course, this I said already was a trinomial because it has 3 terms, 3 things separated by addition. Some more vocabulary would be linear and quadratic. So linear is an expression with a highest exponent of 1. A quadratic is an expression with a highest exponent of 2. So these are names for polynomials by their degree, by their highest exponent. These all, you say, well, they don't have exponents at all, but because they have an x, we can say that their exponent is 1. So on this expression here, that has an exponent of 1, but the highest exponent is 2, which makes it a quadratic. This one doesn't have any exponent at all, so its exponent is 0. Basically, if you have just plain x, can have a coefficient, it's linear. If it has an x to the 2nd power as its highest exponent, then it's a quadratic. And this is important to understand because linear and quadratic are different in the way we graph them and in the way we solve those equations. Linear equations, to solve 3x plus 4 equals 9, we can subtract 4 from both sides and divide by 3. We can use the properties of equality. To graph y equals 3x plus 4, we can use the concept of slope and y-intercept. With quadratics, when you have an exponent of 2, you can't use the properties of equality. You can sometimes, like if there's not a linear term, you can sort of get away with it, but at the end you're going to have to do the square root. So you really can't use the properties of equality to solve a quadratic. We have to have some other things to solve a quadratic. And to graph a quadratic, you can't use the concept of slope because it's not linear. And so it doesn't have a constant slope. In fact, the graph looks like this. It's a parabola. Or it could be upside down like this. It's a parabola. So it doesn't have constant slope. So we need other methods. We can use the x and y intercepts. We can figure out what this point is, the vertex. We can find the axis of symmetry. We can come up with a graph in other ways. But it's really important to understand to look at the problem first and say, is this a linear or is this a quadratic? Because they have different ways of approaching them. This is what we call the standard form of an equation for quadratic. So notice the x squared is first, and then we have the bx. We call this the linear term, and this is the constant term, and it's equal to 0. This is the standard form of a linear equation, where a is not equal to 0, because that would make it a linear, and then a, b, and c are real numbers. So what you need to know from this is that the leading coefficient, the first coefficient, the coefficient of x squared is a, the linear coefficient is b, and the constant is c. And you need to be able to identify those as a, b, and c. Before we can solve or graph quadratic equations, we first have to be comfortable with adding, subtracting, multiplying, and dividing them. When you were in elementary, you learned how to add, subtract, multiply, and divide numbers. And now we're going to explore what that looks like with polynomial expressions. In elementary school, students often model numbers with fun things like bears or pumpkins. We model expressions with algebra tiles. This is what we call x squared, x to the second power. And the reason why is the area of a square with length x. So if I put this over here and this over here, this side length is x and this side length is x. And if you multiply those together to get the area, x times x is x to the second power. And we often call x to the second power x squared because of this, because it's a square. You'll notice that the length of x is 1 and the width of x is, well, it's x. So the area of this, let me move this around here and rotate it. So if I was trying to find the area of this square, it's x times 1, which is 1x. We typically make negatives like a member of the red family. So we have negative x squared and we have negative x is orange and then negative 1 is pink. It depends on the algebra tiles, but those are negatives and these represent positives. And the only other thing to mention about algebra tiles before we start modeling them is that when we put two of them together, that's a zero pair. So x and negative x together cancel each other out. And you might use that concept in the future to make things work out. Like you might have to add that to a diagram to make things work out. Because of course, if I add it, I'm really just adding 0. So I'm not changing it at all. I'm just making it into a form that makes it easier to work with. So to model 4x squared, we would take 4 of these. And 3x, we would take 3 of these. And then for 4, we would take 4 of those. 1, 2, 3, 4. And that's how you model 4x squared plus 3x plus 4. If I wanted a minus 4, I would use some of the pink guys. And that's your introduction to polynomials.